In this presentation, we're going to look at power series. So, the exercise is expand as a power series in terms up to x to the power 4 the following function. So the function is e to the x squared minus x. Okay, so the whole thing is the power x squared minus x. Now, there's a couple of ways to do it, but essentially what we could do is use some standard results. There's a couple of these that relate to the exponential function, the sine function, and so on. Okay, so the exponential of y, or e to the power of y, can be roughly written as 1 plus y plus y squared over 2 plus y cubed over 4. The general term there is y to the power of I over I factorial, which is slightly a little bit weird looking there, but it's if you get the idea, starting from 0. Okay, so yeah, the power y to the power of a number over that number to the factorial of that number. Anyway, so there we have it there. So what we're going to do is put in e to the power of y there. That's just a couple of terms to start us off. 1 plus y squared over 2 and so on. So I have a few more terms down here. So we have 1, okay. We have y, and we're going to put in x squared minus x. And back here we have y squared over 2. So we just sub in x squared minus x. There we have it, that expression there. Now you're probably thinking this is looking pretty clunky. Okay, so what we're going to do is try and get around this. So what we're going to do is we're going to factorize it and see how much that helps us. Okay, so what we're going to do there is we're going to factorize that. So e x squared, or that should be minus x equals 1 plus x times x minus 1 plus 1/2 of x squared x minus 1 squared, okay, plus x cubed times x minus 1 cubed over 6 plus x to the power of 4 times x minus 1 to the power of 4 all over 24. Okay, and so on. I've only gone that far because if we go any further, we're not going to have any terms in. Well, we could actually, but essentially, it's a sort of the law of diminishing returns is now starting to apply. Okay, so that's as far as you can go. We don't have to. We won't go any further with that. You could actually possibly get another term. No, you won't actually. Yeah, that's as far as you can go. If you're just keeping it in terms of x to the power of 4, you don't go up any further. So what we essentially what we have to do here is just simplify it as much as we can, and we also we don't have to go into high powers so much. Okay, so what I'm going to do here is I'm going to sort of break it up into individual terms. Okay, so I have 5 of them there. Okay, now the first two terms, 1 and x times x plus 1, they're pretty much can be left alone. In fact, I'm going to just leave them alone like that. But the rest of them, what we're going to do is we're going to go through them now, and what we're going to do is sort of simplify them out a bit. Okay, so x squared times x minus 1 squared. Okay, so let's look at that one there. So 1/2 of x squared x minus 1 squared is 1/2 of x squared. Now what I'm going to do here is this expression here, I'm going to evaluate it, but I'm going to try and evaluate it from the lowest term up. Okay, so this is 1 plus 2x. Is that plus 2x? No, it's minus 2x. Okay. Okay, so when I multiply that x squared by 1, I get x squared. When I multiply that x squared by 2x, I get a power of x to the 3. Plus x to the power of x squared. Okay. And so on. So when I multiply that through, the highest power there is going to be x to the 4. Okay. So far so good. Now that one wasn't so interesting, but it's sort of my modus operandi is going to become a little bit clearer now. So I'm going to move on to the next one here. And this is 1/6 of x cubed times x minus 1 cubed. Okay. So x minus 1 cubed is, this is important now. So what we're going to do here is, again, we're going to start off with the lowest term, and when we multiply that out, it'll be 1. Okay. The next term is going to be, or it'll actually be minus 1. The next term is going to be 3x, and it will be plus 3x. Okay. And after that, the next term will be something, but actually I don't have it written down. But you see, the thing is, when we multiply it by x cubed, or 1/6 times x cubed, it'll actually have too high a power, so I'm not going to include it. That's what I'm sort of getting at. Essentially what I'm going to do is, if I was to include any more terms from here, they are going to have powers higher than x to the power of 4, so I'm not going to include them anyway. So essentially what I'm going to do is I'm just going to stop here. Okay, that's we've ended it there. We're going to do this one more time. So we have 1/24 times x to the 4. Okay, I'll just bring that bracket out. Times x minus 1 to the power of 4. Okay. Now, let's be careful about this. There's only going to be one term here that will have x to the power that we can use. So 1/24 times x to the 4. If we multiply x minus 1 squared out, we would start off with a plus 1. And then we would have a term in terms of x. But we're not going to use it because it's automatically too high. Okay, so the only actual term we're going to use here is 1. The rest of the expression will be just too high. So we're not going to use it. Okay, so that's all the expressions we're going to use. So essentially the thing is, after a while we stop. We didn't stop here. We got to the end without needing to stop. Okay. We stopped, if that's for the first one, or that first one there. The second one, we only got as far as 2 in, okay, the minus 1 and the plus 3x, and so on. And then finally, in the last one, we only needed the first term. So we're going to put this all together now. And what we have here is the first two terms, which is 1 and x squared minus x. Okay. Then the next term, which is 1/2 x squared times, what was it, x squared minus 2x plus 1. Then the third term, which is 1/6 x cubed, and what we had there is 3x minus 1. And then the fourth term is 1/24 x to the power of 4 times 1. Okay, and after that we're not including any more terms. Well, we could, but we'll just put a little ellipsis just to sort of say that there's other terms not included. Essentially what we're going to do now is just sort of simplify this. I'll just take that ellipsis out so you should know what's there now. 1 plus x squared minus x plus 1/2 of x to the power of 4 minus 1/2 of x to the power of 2 times x, 2x cubed. Okay, essentially the half and the 2 cancel out. We also have a minus sign there, so I'll just tidy that up a bit. Plus 1/2 of x squared. 1/6 of x cubed times 3 of x. 1/6 times x cubed times 3 of x. That 3 and the 1/6 cancel out to a half. And also we're putting it to the power of 4. X cubed times 3 of x. Okay. Minus 1/6 of x cubed, just multiplying that by 3. Multiplying the 1/6 to the x to the power of 3 by minus 1. Okay. And then finally x to the 4 over 24. Essentially what we do is we gather up all the like terms and just simplify the problem. So what we have here is just, well, we just have one polynomial of degree 0, so that's 1. We have, I'm just going to, one polynomial of degree 1, or x to the power of 1, that's minus x. Okay. So now what I'm going to do is look for the x squared terms. We have x squared, half of x squared. That's it. So plus 3 over 2 x squared. Now we look for the x cubed terms. So we have that x minus x cubed there, and minus 1/6 x cubed there. Okay. So that is minus 7 over 6 x cubed. And finally all the rest of it there, a half of x to the power of 4 plus a half of x to the power of 4 plus x to the power of 4 over 24. So add them all up together. The x over 4's, so this term here and this term here just gives us x to the 4. And that just gives us x to the 4 of 24. So essentially what we have here is plus 25 over 24 x to the power of 4. And that is the answer we're going to work with. Okay, so that's how we do it. Now, something that could be very useful in these sort of situations I'm going to talk about is binomial coefficients and so on. So I'm just going to talk about, I'll do that in another presentation, but there is a way, binomial theorem, and of evaluating those quickly. Okay, I'm just going to sort of say that for another presentation. So this is power series.